Hello, Bronx Middle School Math. Today we are continuing with Lesson 3, and this focuses on the how we can use attributes to classify shapes, specifically with quadrilaterals, trapezoids, and parallelograms. Let's begin. So, what did we learn in Lesson 2? These were the main ideas that we went through in Lesson 2. So, question 1. Using our new understanding of what characterizes a trapezoid, justify in your words why not all trapezoids can be parallelograms. So remember this picture? This picture is a great example of how all parallelograms are trapezoids, but not all trapezoids are parallelograms. So let's just go by the definition. What is the definition of a trapezoid? So the definition of a trapezoid is that it must be a quadrilateral, meaning it has to have four sides. So it must be a quadrilateral with at least one pair of parallel sides. Okay, so let's start from that. And then a parallelogram must have two pairs of parallel sides, and it's also a quadrilateral. The key word that we must look at is at least. So a trapezoid must have at least one pair of parallel sides. This indicates that it's possible for trapezoids to have two pairs of parallel sides. So it's possible for trapezoids to have at least two pairs of parallel sides. And if a trapezoid does have two, then it's a parallelogram also. It's not, when it comes to geometry, it's not one or the other. It can be both. All parallelograms fit the rules for trapezoids, but not all trapezoids fit the rules for parallelograms. So, like we said, a parallelogram is a quadrilateral with at least two, not with at least, a parallelogram is a quadrilateral with two pairs of parallel sides. So it's automatically going to have at least one pair of parallel sides, which automatically makes it a trapezoid. Here's another great response. Pause the video and read the paragraph to the right. I underlined some of the most important concepts in this paragraph. All parallelograms are classified as trapezoids because all parallelograms have at least one pair of parallel sides. And the second point that's really important to take away is that not all trapezoids are classified as parallelograms because not all trapezoids have two parallel sides. Okay, so let's go to this picture on the left. This is a great diagram that we need to break down and understand. So the pictures on the left, the green shape, the blue shape, and the red shape. Let's break these shapes down. Okay, I want to dissect these shapes one by one. So let's start with this green one. What are some vague observations that we can make? Well, 1, 2, 3, 4. Okay, so the most basic observation that I can make is that it has four sides, and that makes it a quadrilateral. So y'all know, any shape that has four sides, it is a quadrilateral. Well, I meant to draw. My bad, y'all. There we go. Check. It's in the quadrilateral family. Now let's make some more specific observations. Okay, well, I see one pair of parallel lines right here. That's one. Okay, so because I see one pair, I know it's going to be in the trapezoid family because it has at least one. So it has four sides, it's in the quadrilateral family, and I see right off the bat there's already one pair of parallel lines, so it's in the trapezoid family. Okay, now I'm getting more specific. Oh, there's another pair. Okay, so I'm getting more specific, and I just found another pair of parallel lines. So now I see it has two pairs of parallel lines. So now that I've found that second pair of parallel lines, I know it's in the parallelogram family. And remember, it's not one or the other. It's all of them. It can be all at once. It can be all at the same time. So this green shape is a quadrilateral, a trapezoid, and a parallelogram, all at the same time. Okay, let's move on to this blue shape in the center. So again, we are breaking these down and starting from vague descriptions and getting as specific as possible. Okay, so I'm being vague. 1, 2, 3, 4. Okay, so it has 4 sides. What does that make the shape? A quadrilateral. Okay, well, can you be more specific? Okay, well, I see parallel lines. So I can get closer and say it's a trapezoid. Okay. And some more attributes that I'm seeing is that it has a second pair of parallel lines, which means it's in the parallelogram family. And some more attributes that I'm seeing will be the 4 right angles. So that means it's a rectangle because opposite sides are congruent. So when you see the right angles and opposite sides are congruent, it's a rectangle. So look at this. This shape, this blue shape is a quadrilateral, and it's a trapezoid, and a parallelogram. And the most specific name we can give it is a rectangle. You want to start vague and get as specific as possible. And the way we get as specific as possible is through classifying and recognizing the attributes that shapes have. Now we are going to do the final shape, the red shape at the bottom. Okay, remember, we start vague. Well, I see 1, 2, 3, 4. Okay, so I know it's a quadrilateral. It has 4 sides. Now let's get more specific. Okay, are there any parallel lines? Yes. I see 1, so it's a trapezoid. I see another, it's a parallelogram. Okay, I see 4 right angles, and opposite sides are congruent. So I know it's going to be a rectangle. But wait, the opposite sides aren't only congruent, all 4 sides are equal. So since we see at first, we go, okay, opposite sides are parallel and they're congruent. We know it's a rectangle. But then we get more specific and we're like, oh, not only are opposite sides congruent, but all 4 sides are congruent. All 4 sides are equal. So we know it's a square. Square is the most specific name that we can come up with the shape. So remember, we start vague with the quadrilateral and we get as specific as possible, and we get there through using and recognizing the attributes. One of the concepts that I noticed that was common in the exit tickets that y'all turned in was that a lot of people thought that a trapezoid could only look like this one. That's not true. All of these shapes are trapezoids. Remember, any shape is a trapezoid as long as it has 4 sides and at least 1 pair of parallel lines. Let me repeat that again. Any shape can be a trapezoid as long as it has 4 sides and at least 1 pair of parallel sides. There is no one right way to be a trapezoid. A trapezoid can come in many different shapes and forms. Or I shouldn't say different shapes, but different forms. There are many ways that a trapezoid can look like. This is a trapezoid. This is a trapezoid. This is a trapezoid. And we are about to get into why these are trapezoids, but why they look different. So just as we did with the shapes on the left, we are going to do with these shapes right here. We start broad and use the attributes to get the most specific classification. So let's begin. Okay, 1, 2, 3, 4. So I know it's a quadrilateral. Check. Okay, let's look for other okay, I see one pair of parallel lines. Okay. Are there any other attributes that we could use to help classify? I'm not seeing any. So what I have here is that we have 4 sides, so we know it's quadrilateral. One pair of parallel lines, so it's a trapezoid. I don't see another, so it's not going to be a parallelogram. This is just a trapezoid. Okay, let's move on to the middle one. Remember, start broad, work your way in by recognizing attributes. 1, 2, 3, 4. Quadrilateral. Okay, what attributes do I see? So this line is straight, because if it continues, it's going to be straight. But if this line continues, oh, it's going to eventually cross. So these lines are not parallel. These lines will intersect at some point. But these lines, look, those are parallel. So we have one pair of parallel lines. Trapezoid. Is there another attribute that I can... Right angle. Here's a right angle. So the most specific title through using the attributes that I can find is that this is a right trapezoid. Because we are using the most specific attributes to categorize it. It is not a parallelogram because look, there's only one pair of parallel lines. So now we're going to do the very last one. Okay, remember, start broad. 1, 2, 3, 4. Quadrilateral, check. Parallel lines, there we go. So we know it's a trapezoid. These lines are not parallel because look, they will eventually cross. So it is not a parallelogram. Are there any other attributes that I could see? Well, these angles are obtuse. And these are acute, but that doesn't tell me anything. So those facts don't really matter right now. But what does matter is that we were able to use the attributes to find out that these shapes are all trapezoids. Remember, there is not one correct trapezoid. As long as it has 4 sides and at least one pair of parallel lines. Remember, there is no one correct form of a trapezoid. As long as it meets these characteristics and meets these rules, it's a trapezoid. So the trapezoids on the left are trapezoids that can also be classified as a parallelogram. In the trapezoids on the right, these are trapezoids that cannot be classified as parallelograms because they only have one pair of parallel lines. These shapes have 2, so they are both trapezoids and parallelograms. These over here are only trapezoids, not parallelograms. The second question on the exit ticket was, draw a quadrilateral that is not a trapezoid. Explain how you know your shape is not a trapezoid. Well, let's begin by remembering we have to draw a quadrilateral, so it has to have 4 sides. So we can know a shape is a trapezoid if it's 1, a quadrilateral, and 2, has at least one pair of parallel sides. So we need to draw a shape that does not have any parallel sides. So that is our rule that we need to follow. If you look at these 2 shapes here, we can see 1, 2, 3, 4. It is a quadrilateral, but there are no parallel sides in this one, so it meets all the rules. Let's look at this one. It's a kite. 1, 2, 3, 4. Quadrilateral? Yes. And remember what we said about a kite. The sides are adjacent. This side is adjacent to this side, and they are congruent. So let me say that in irregular terms. This line is next to this line, and they're the same length. And this line is next to this line, and they're the same length. But notice how these lines are not parallel, because look, they're eventually going to cross. They would cross somewhere up here. And same for this line. It would eventually cross right here. So we know both of these shapes are quadrilaterals and do not have parallel sides. This is another form of a kite. You can see because it's 1, 2, 3, 4. I'm sorry, I did not mean to say kite. I meant to say quadrilateral. This is another form of a quadrilateral. But it is not a trapezoid because look, no parallel lines. Now let's review from the main points of yesterday. What makes a shape a parallelogram? I want you to pause the video and answer these questions, and then once you have your answer, start the video again. What makes a shape a trapezoid? What do these two shapes have in common? What is this shape? Is this shape a trapezoid? How do you know? We know a shape is a parallelogram when it is a quadrilateral, so it has to have 4 sides. And there are 2 pairs of parallel lines. Another attribute of a parallelogram is that opposite sides are parallel and congruent in length. We can see that in a rectangle, parallelogram, rhombus, and square. What makes a shape a trapezoid? A trapezoid is a quadrilateral, meaning 4 sides, with at least 1 pair of parallel lines. What do these 2 shapes have in common? Well, we know both shapes are quadrilaterals because we see 4 sides. And both have at least 1 pair of parallel sides. So both of these shapes are trapezoids. Let's make our list. Okay, we are going to dissect these 2 shapes. Remember, we start broad and get as specific as possible using attributes. So let's start with the figure on the left. Okay, we start broad. 1, 2, 3, 4. It's a quadrilateral. Trapezoid, the blue lines are parallel, so I know it's a trapezoid. The red lines are parallel, so I know it's a parallelogram. Okay. So then now let's do the figure on the right, this one. 1, 2, 3, 4. It's a quadrilateral. Okay, I see these lines are parallel, so there's 1. It's a trapezoid. These lines are not parallel because look, they continue, they're going to cross. So the lines are not parallel. So it cannot be a parallelogram. So what do these 2 shapes have in common? Well, they're both quadrilaterals and they're both trapezoids. And look, it says exactly what we just did. Both follow the rules for the trapezoid classification, but the shape on the left has 2 pairs of parallel sides, so it's a parallelogram. Okay, so let's do the shape. Is this shape, and I'm talking about this one, is that shape a trapezoid, excuse me, y'all? No, this shape does not have 4 sides. Yes, it has parallel lines. Those are parallel. These are parallel. All sides have a parallel partner, but it needs to have 4 sides. In order to fit the rules for a trapezoid, it must fit both rules. So it must be a quadrilateral and it must have at least one pair of parallel sides. Y'all know this. Okay, now let's do this bottom shape. Is this a trapezoid? Yes, because it has 4 sides and at least one pair of parallel lines. We know it's a square, so we know it's going to be a quadrilateral, a trapezoid, parallelogram, and a square. Okay, is this top shape? Is this a trapezoid? Yes, because it has 4 sides and at least one pair of parallel sides. And remember, we said earlier this would be a right trapezoid because of that right angle. Would this bottom figure be a trapezoid? No. Because although it has 4 sides, it does not have parallel lines. And remember, we said that with the hexagon. It doesn't matter if you have at least one attribute, you need to have both attributes. You need to have 4 sides and at least one pair of parallel lines. A trapezoid has at least one pair of parallel sides. A parallelogram has 2, meaning that some trapezoids are parallelograms. That's a tongue twister. But remember, all parallelograms are trapezoids. And that is because they already have at least one pair of parallel sides. So if I have 2 donuts, don't I have at least one donut? You bet I do. Remember, it's important to know and understand that not all trapezoids are considered parallelograms because they might not have 2 pairs of parallel sides. If a shape has 2 pairs of parallel sides, it's going to be a trapezoid and a parallelogram. So let's break down each one. So this shape is a quadrilateral that fits the rules for a trapezoid and a parallelogram. This is a quadrilateral that fits the rules for a trapezoid, but not a parallelogram. That's because there's only one pair of parallel sides. In this shape, the kite, fits the rule for quadrilateral, but not for trapezoid, and not for parallelogram. It's neither. It is just a quadrilateral. Mini lesson. So the purpose of this is to show you that trapezoids come in many forms. There is not one right way for a trapezoid to look. I had several scholars that said a trapezoid had to look like this and this only. That is incorrect. Trapezoids can come in many forms, and we are going to look at that. Okay. So look at this. There can be trapezoids with no right angles. There could be trapezoids with only one obtuse angle. There can be trapezoids with at least one right angle. And there could be trapezoids with 2 obtuse angles. So look, all of these shapes are trapezoids. Look at how many different forms trapezoids can come in. Let's pause the video and let's list the attributes for each of these shapes. Okay, let's break down this no right angles one. So we know it's a quadrilateral, 4 sides. Here are the parallel sides, so it's a trapezoid. Let's go over to the one with the obtuse angle. 4 sides, quadrilateral. These are the parallel sides, trapezoid. Can you find another attribute? Yeah, there are 2 right angles. That would make it a right trapezoid. Let's start with this rhombus here. So that's the most specific name for this shape, a rhombus. But remember, it's going to be in the category of quadrilateral because it has 4 sides. Trapezoid? Yeah, I see a pair of parallel lines. And these are parallel too. So it's going to be a parallelogram. And opposites, all sides are congruent. But there are no right angles, so it's not a square. Notice how this shape right here, that has right angles, so it makes it a square. It has all the same attributes as this rhombus, such as 4 sides, 2 pairs of parallel lines. All 4 sides are congruent, but the only difference is the right angle. So now we are going to come up with all the possible names that the quadrilateral can have. Take 30 seconds to write down all the names and categories this shape goes into. So remember, it takes practice to start getting the hang of things here. Practice makes perfect. I know it's corny, but it's true. So we start broad. How many sides? I'm supposed to be on drawing mode. 1, 2, 3, 4. So quadrilateral, check. Any parallel side? Yeah, these are parallel. So trapezoid. And line 1 and line 3 are also parallel. So it's a parallelogram also. Let's look at these and see what we can come up with. Pause the video and list all the classifications. Let's begin with the shape on the left. We see it has 1, 2, 3, 4. These are parallel, trapezoid. These are parallel, parallelogram. Now, when a shape's like this, it's assumed to be a rhombus because it's not flat. So we can assume that the most specific name it can come up with is a rhombus, because all 4 sides are congruent in length. Now let's do the one on the right. Remember, vague and work your way in. 1, 2, 3, 4. It's a quadrilateral. These are parallel, so it's a trapezoid. These are parallel, so it's a parallelogram. What are some other attributes that we can use? Okay, so opposite sides are congruent. Those are the same length, and those are the same length. And there are 4 right angles. So because there are opposite sides are parallel and congruent, plus the 4 right angles, we know it's a rectangle. So a rectangle is the most specific name that we can get for this shape. During the discourse, we're going to be asking some questions, and after we ask the questions, pause the video and think about your answer. Make sure you have a reasoning behind it. What makes a shape a rectangle? What makes a shape a square? Write down the attributes, and we can figure out through the attributes why it's classified as a rectangle and a square. So remember, we have to start broad and work our way in. First, we realize that it has 4 sides, so it's a quadrilateral. So 4 sides, quadrilateral. Then we see, okay, the blue lines are parallel, trapezoid. Oh, and the red lines are parallel also. So 2 pairs of parallel lines right here. 2 sides are parallel, parallelogram. Then opposite sides are congruent in length, and there are 4 right angles. So the most specific name we can come up with for this shape is a rectangle. Let's move on to the bottom shape. Remember, we start broad and work our way in. So it has 4 sides, quadrilateral. I see a pair of parallel lines. Trapezoid. Another pair of parallel lines. Parallelogram. Now I notice that opposite sides are parallel and congruent. So what would that make it? We just said that up here, that it would be a rectangle. That's right. This shape will also be classified as a rectangle because the opposite sides are parallel and congruent. So opposite sides go in the same direction and they have the same length, plus the 4 right angles. But we don't just stop there. The last attribute that we use to classify this shape is the fact that all 4 sides are congruent in length. Look, all 4 sides are equal to each other. All 4 sides are the same length. And because of that, that's the different factor between the square and the rectangle. So, because of that, it is also in the square family. That is the most specific name that we can come up with this shape. Remember, we use attributes to get to the most specific name for a shape. What do all these shapes that we have discussed over the past 2 days have in common? If you are given a trapezoid or a parallelogram, how can you determine if there is a more specific name for that shape? And what is that name? Or excuse me, what that name is. Take 30 seconds for each question or however long you need. Just make sure you are able to understand and defend your answer. There's a lot of writing on this page, so let's pause the video and read it. But the overall theme is that all the shapes we've looked at have been polygons. Remember, a polygon is any shape with at least 3 sides. So that includes triangles, quadrilaterals, pentagon, hexagon, and so on and so forth. Another problem that I saw with y'all's exit tickets is that people were getting trapezoid confused with triangle. Remember, triangle is any shape with at least 3 sides. And a quadrilateral is any shape with at least 4 sides. So that could be rectangle, square. We've just gone over all the different types of quadrilaterals that there are. Trapezoids, parallelograms. That is the vague description. And remember, the main idea that we've been going over is that shapes can have different classifications, but we use their specific attributes to get down to their most specific name. Changing one attribute can change the shape's entire classification. Remember how we said with the rectangle? Look, all we did was change opposite sides are congruent in length to all 4 sides are congruent in length, and you have a completely different shape. So yes, details matter. Remember, all parallelograms are trapezoids, but not all trapezoids are parallelograms. This is a really important question that I need y'all to understand and really ponder over. So take however long you need and think about this question and have your answer ready. So, the quadrilateral hierarchy. A rectangle is a quadrilateral with 4 angles. Both pairs of opposite sides are parallel. Therefore, rectangles can be classified both trapezoids, at least one pair of parallel sides, and parallelograms. So notice how we start vague and we get more specific. So we go from just being told, oh, so pretend we're playing a game and I'm thinking of a shape and you have to guess the shape that's in my head. So let's say the shape that's in my head is a square. And you start off with vague questions. Okay, how many sides does it have? It has 4 sides. Okay, so you know it's a quadrilateral. Okay, is there at least one pair of parallel sides? Yes, there's at least one pair of parallel sides. So you know it's a trapezoid. Is there another pair of parallel sides? Yeah, there are 2 pairs of parallel sides. We know it's a parallelogram now. Okay, well, are there any right angles? Yeah, there are 4 right angles. We know it's a rectangle now. Okay, are opposite sides congruent? Yeah, opposite sides are congruent in length. Well, that is still the classification for a rectangle. So you're still where you were. What's a better question that you could have asked? Are all 4 sides congruent in length? Yeah, all 4 sides are congruent in length. So you can form the image in your head to come up with the square. A square is a quadrilateral with 4 congruent sides. Since a square has 4 right angles, it can be classified as a rectangle. A square has opposite sides that are parallel, so it can be classified as a trapezoid and a parallelogram. Where squares are always classified as rectangles, parallelograms, trapezoids, and quadrilaterals, rectangles, parallelograms, trapezoids, and quadrilaterals can be classified as square sometimes. Rectangles can only be classified as squares if all the sides are congruent. Parallelograms, trapezoids, can only be classified if all the sides and all the angles are congruent. So that's a lot to take in. So let's break that down. What this paragraph is saying is exactly, let me get there. We have to go back a bit. So what that paragraph was saying is what this image is expressing. So all parallelograms are trapezoids, but not all trapezoids are parallelograms. So what that paragraph was saying was that all squares are rectangles, but not all rectangles are squares. An example that I used with my class today is what you would say to somebody when they ask you where you're from. So if somebody asks you where you're from and you just say North America, the other person doesn't know. Well, are they from Canada? Are they from the USA? Or are they from Mexico? That's not specific. So saying you're from North America is like saying you're a quadrilateral. It gives us an idea, but it's not specific. So let's zoom in a little bit more. So you don't just say you're from North America, you say you're from the United States of America. Okay, well, the United States of America is in North America. The USA is in North America. So that would be like saying you're a trapezoid because the USA is always in North America. So trapezoids are always quadrilaterals. So since trapezoids are always quadrilaterals, that's the same as saying the USA is always in North America. It is. The North America is made up of Canada, the United States, and Mexico. So is Canada in the United States? No, it's not. So just as saying all quadrilaterals are not always trapezoids is saying Canada's not in the United States. You can say Canada is in North America. That would make sense. But it's not in the United States. So not all countries in the continent are in America. But let's get more specific because the USA is pretty big. So let's say I'm from Texas. So let's go with Texas. So somebody asks you where you're from, and you start off with, I'm from North America. Well, that's vague. Let's boil it down a bit. I'm from the USA. Still pretty vague. There's a lot of states in the USA. I'm from Texas. Okay, that's specific. There we go. So, is Texas in the United States? So when I say I'm from Texas, you assume I'm American because I am. Texas is in America. So all Texans are Americans. Just as all parallelograms are trapezoids. So all Texans are Americans, but not all Americans are Texans. So most of the scholars watching this are from the Bronx. Y'all were born and raised in New York City, the Bronx. Y'all are American. So y'all are American. Does that mean you're Texan? Probably not. Unless you were born and raised in Texas, you're not Texan. So just because you're a trapezoid, just because you're American, does not mean you're a parallelogram. Does not mean you're Texan. So let's repeat that main idea. All Texans are American. Yeah, because Texas is in the United States. But not all Americans are Texan. Yeah, because if you're from California, right here, you are not in Texas. You are not from Texas. Or if you're from New York, you're American, but you are not Texan. So say it again. All Texans are American, but not all Americans are Texan. So let's put that in geometric terms. All parallelograms are trapezoids, but not all trapezoids are parallelograms. So when I travel and I meet someone and they ask me, "Where are you from?" and I say, "Oh, I'm from Texas," they would assume and they would know that I'm American. If they asked me after I said, "I'm from Texas," if they said, "Oh, so are you American?" I would wonder why they would ask me that, because everyone would know Texas is in America, and that makes me American. So all parallelograms are trapezoids, but not all trapezoids are parallelograms. Remember, shapes in geometry, especially quadrilaterals, it doesn't have to be one or the other. You don't have to be a parallelogram or a trapezoid. You can be all at once, and we can see that here with this quadrilateral hierarchy of a square. You don't have to choose which category or family that you're in. You can be in all families and all categories at once. All right, y'all. I hope this video was helpful, and stay tuned for the next video that's going to be coming out soon over lesson 7, where we will go into triangles.